But my name is Randall, and today we're going to be talking about WebAssembly and its impacts on innovation and how it's better together with all things cloud native. I'd like to point out that I'm here for you guys, the people here. So don't hesitate to put your hands up if you have a question or comment in the moment as we're going through this. I can pivot through other slides and information. Here's your QR code. If you get your phones out, there'll be a couple QR codes tonight, including the ability to install Wasm right from your phone. So get that out and follow along tonight. You can have fun. This is a connection to me right on LinkedIn. My background is serial open source entrepreneur. I helped to build the BroZ community nearly 20 years ago at this point, just large-scale network monitoring. I launched the very first commercial Kubernetes distribution in 2014, right after Kubernetes was released. I sold that to a big financial conglomerate, where I then went on to write the seed check to the OS Query team at Facebook. If you're a security person, that's endpoint security monitoring. I helped to create CNCF wasmCloud, which is about to go incubating here tonight. And then I presently lead, I'm the CEO of Cosmonic and chair of almost all the Wasm events, WasmCon, Wasm Day, all the things. I really believe that Wasm is the next epic of computing. And I hope by the end of this conversation, you do as well. I'm really easy to find on all the social media, or don't hesitate to reach out if you have any questions or how to get started. I'd like to maybe start with a quick question on who are you? And I want to call out a couple different roles over here on the right and ask you just to raise your hand if you fall into one of these categories. Could developers or people that identify as developers raise your hand? Okay, a couple developers. Platform engineers. Similar group, okay. Management, okay, you definitely care. Security, and then a DevOps. Okay, and then a couple unknowns. Maybe tell me later what your personas are. I'm curious because WebAssembly is really a part of a greater story about the ethics of technology. And if you have been in this industry for 20 or 30 years, like I have, you'll start to recognize a pattern here, where the industry gets together around the common complexity that haunts us all, agrees on an abstraction that's common, that's portable, and that we then adopt to move forward as an industry. Now, what's common about all of these epics of tech is that they're bottoms up. We started first with virtual machines, and there's one that's missing here. Right after virtual machines, we said, why are we, co-locating each application with a physical computer? That's so much waste, that's so much overhead. And then we started to say, why are we even building our own data centers? Let's go all in on the public cloud. And then we said, well, why are we having development teams manage their own operating systems? It'd be great if we had an abstraction there. Then we moved to containers. And then we said, well, why would I write my orchestration for just one cloud? Why don't we have an abstraction for our common orchestration? And WebAssembly embraces the next common complexity that we have in our lives, which is in the applications themselves. And we're going to talk today about containers are wonderful, but what containers are not solving for us, and how that haunts all of you as personas, developers, platform engineers, management, and security. Really, as a developer or as a platform engineer or in management, when you specify these application architectures, you're really asking yourself two different questions. What should the platform provide, and what should each development team provide? And today, as we live and breathe and are successful in the age of Kubernetes and the epic of containers, we're still leaving far too much variability to each individual application. And that translates into an overwhelming amount of maintenance. Now, I don't know how many people are here from the DoD, but even if you're not in the DoD, you probably suffer from an application development process that looks very similar to this. If you build anything that matters, you need to check all the boxes. And if you're in financial services, I'll share the slides, by the way, too. If anybody just asks, you can send me an email, on LinkedIn, I'll email you the deck. You can have them all, go forward and prosper. Or a sample of banking software, financial regulations. When we're talking about drawing those lines between platforms and applications, what we're really doing is we're deciding where does the development team pick up in this process and where does the platform pick up. And the more we leave to developers, the more variability we have, and the more work we're essentially completing in replicate over and over and over again. Because the reality is, containers are a huge step from having people manage their own operating systems but containers do not fix applications. And there's 3 problems that WebAssembly very specifically addresses that we're going to review that has helped to power its phenomenal growth and adoption. And for anybody that's WebAssembly curious or hasn't heard, who's heard of WebAssembly before? Everybody, that's wonderful. Who's using WebAssembly? Okay, I would actually argue you're all already using WebAssembly. WebAssembly has already crept into your life in so many different ways. We'll review that momentarily, but these are the 3 reasons why. The first is that the cold start time of containers is still measured in seconds or half a second. Even in highly optimized containers like those that we find in AWS Lambda suffer from what's called the cold start penalty. And what that means is that if you run a platform or a set of applications, you're always on. And if you want your applications to be responsive, you have to run more copies, which means that they're not only always on in one place, they're always on in lots of places. So we sort of suffer from this lower bound problem of needing to run within 200 milliseconds, or depending, maybe you're at a video game company, you need to run within 30 milliseconds of your users. You have to run all of this always on capability. And that translates directly into huge cost in development. The second problem that containers suffer from is portability. When we are building containers, first, they're tightly coupled to Linux, which is usually okay, but not always. And second, they're specifically compiled for a CPU architecture like x86 or ARM64. We're already seeing the rapid rise of RISC-V, RISC-V, and I think that as a paradigm will continue to grow. You'll have more choices as you move further out towards the edges. The third is that applications embed their libraries and dependencies into each app at compile time versus runtime. And what that means is that your applications are out of date as soon as you start them. What I'm going to try to prove to you over the next 20 to 30 minutes is that...
Could you try again?
Okay, that's what we're trying, Siri. What I'm going to try to prove to you over the next 20 to 30 minutes is that this WebAssembly standard called WebAssembly component is essentially the new container. It's the new portable artifact that we can all share. We can build an ecosystem around it, and it's portable across various runtimes. So let's start with this golden template, with the cost of free. The reality is when you're building your applications today, they are probably 95 to 99% just open source software. Who builds in Java or has applications in Java at their work? Anybody? All right, so you're a Java Spring Boot shop probably, and your team is smart. You want to help your developers. So you give them a template that has all the boxes up to date and pre-checked on day one. And as soon as you hand it off to them, it's out of date. And it starts to drift. It's like the Michael Keaton movie where there's a copy of a copy of a copy in the environment. The large enterprises that we're working with are typically building between 4,000 and maybe 7,000 unique microservices. And Java still largely dominates that space today. And this cost of managing and keeping free software up to date is crucifying developers. And generally, we would estimate that developers are spending 80% of their time on operation and maintenance. What are they maintaining? That 90% or 95% of free software that composes the multiple pieces of your application. You're not changing your business logic every 30 days, but you are changing a lot of yellow and red boxes back to green. You've basically turned your developers into boilerplate farmers. So if we dive on this a little bit further, you probably recognize a Docker file. We'll see this image a little bit later. But each one of our images, our applications, has become a pet. And the application component, you probably have a DevSecOps team that's managing all these other layers and can inject the latest containerized update at compile time. But the development team still own this app. And within this app are hundreds or thousands of possible embedded vulnerabilities and dependencies. This tight coupling means that while the last decade has been okay because it's been primarily driven by this great lift and shift into the clouds, the next decade is really about bringing our compute to the data. And on those edges, we're finding a diversity of operating systems, CPUs, and architectures, which means we need systems that can account for that. And then finally, that cold start problem. This is an image from a great paper. I can link it at the end that really talks about the cold start time for even highly optimized containers on Kubernetes is still typically measured in seconds. WebAssembly has a cold start time between 5 and 50 microseconds. And what that means is network transactions are governed in milliseconds, right? So if I'm a video gamer, I want to be within 30 milliseconds of you. When WebAssembly has a cold start time of microseconds, we can start per invocation and shut back down. I mentioned a moment ago that you're already using WebAssembly in your day-to-day life. The future is already here, it's just not evenly distributed. Who's heard of Fastly and Cloudflare? Well, wonderful. Cloudflare uses V8, which drives WebAssembly underneath the hood. V8 is the browser, is the engine behind the Google web browser. Fastly uses the same engine that we've used, which is called wasmTime, which is a native server-side runtime to orchestrate their WebAssembly. So WebAssembly has already been adopted across numerous places. But the net of this is that developers are spending too much of their time on operations and maintenance. So what the heck is WebAssembly? Well, first, it's a terrible name. It's neither web nor assembly when it comes down to it. And we're actually going to look at WebAssembly momentarily. But the key things about it are, first, is that WebAssembly is a truly open W3C standard. The W3C standardizes 4 languages: HTML, CSS, JavaScript, and now WebAssembly. So the 4th language of the web is kind of a big deal. It was designed with first principles in mind. And when we look at the architecture of WebAssembly in a little bit, each WebAssembly module has separate memory space, has separate tables, and separate globals. It's very efficient and fast. It was originally part of this hack by a developer named Alon Zakai. Maybe you may remember Slashdot or the Reddit homepage in 2012, but this Alon Zakai had one of these ideas that was so terrible it might even have been brilliant. He said, what would happen if I transpiled C code to JavaScript? Would that be a good idea? And sure enough, he had Doom running in a browser shortly thereafter. The WebAssembly team, the core engine team at Firefox, their core engine is called SpiderMonkey, took note of this and started to highly optimize it. And that is the genesis story for WebAssembly, is that set of tools. So it's efficient and fast, and it was designed for the most dangerous place in the world, the raw internet. It's polyglot, so it's a compilation target. Many languages can compile down to this, and it's really portable. It's got broad industry adoption, and in addition to the incredible support that Chris and his team provides at the CNCF, not only through Wasm Day, but also the new WasmCon conference, there is a separate trade association called the Bytecode Alliance. There's stickers in the back if you'd like some, that has some of the largest players in tech to collaborating on building this as a truly open standard. I'm here as one of the small startups, but I'm very fortunate to say that my CTO, Bailey Hayes, is the co-chair of WASI, which is one of the key standard groups that's out there. This is a really active, fast-moving space, and WebAssembly already runs natively in Kubernetes and Docker, right? Things are moving incredibly fast in this space. So how do you think about WebAssembly? Like, mentally, you need that model in your mind. The easiest way to think about WebAssembly is as the world's smallest virtual machine. And in fact, WebAssembly is really just 3 integers in a trench code, right? Numbers come in and numbers go out. But from that basic foundation, we've been able to build a really powerful ecosystem that we're going to demonstrate that allows you to take modern applications and start compiling them to run everywhere. We'll deep dive on that a little bit more. But within WebAssembly in the last year, we're working on right now the next big release. It'll be called WASI.2, or the WebAssembly System Interface. And what WASI.2 defines from WebAssembly is this idea of a WebAssembly component. You know, you could take anything and compile it into WebAssembly today. And in fact, you see all the stunt hacking in WebAssembly. People are transpiling operating systems and letting them run in your browser, right? Somebody's created a virtual x86 chip that lives in WebAssembly that you can run in a container on Kubernetes on a virtual machine in the public data center in a public cloud all the way down. But I don't think that the stunt hacking is the real future of WebAssembly. The real future of WebAssembly comes in these standards where we start to model the core building blocks of modern applications. Things like key value stores, databases, web servers. And these standards are modeled through an IDL. Jonas, if you could hand out those cheat sheets, called WIT, WebAssembly Interface Types. You should have these. You can also find this on our website at cosmonic.com if you want a digital copy. And with this IDL, this interface definition language, we've modeled these template interfaces that you can use to compose your apps. Now what that means is that underneath the hood, these interfaces become hot swappable. They can be independently versioned. You can start your applications with the most recent version at runtime versus compile time. And if you've ever developed on top of Cosmonic or wasmCloud or Cloudflare or Fastly, then you're familiar with this model where you simply then write just your business logic, which today composes probably 5% of your code, and now 95% of your work has been lifted out of your life. And we'll look at some applications momentarily here. We published a case study with Adobe last year, and we're publishing a case study right now with a telco consortium that includes Vodafone, includes Orange, NBN, and a bunch of other telcos that sort of documents their progress here with their applications. But these applications are, in some cases, were being migrated from Java Spring Boot. So in Java Spring Boot, in memory, in the Adobe case, each app consumed 2 gigabytes of memory. When they created it as a WebAssembly component, it now only took a couple hundred kilobytes of memory, over 200 times smaller. Each individual component can be individually scaled or auto-scaled to meet the load and demand. Whereas when everything was all bundled together in a giant app, you had to scale the entire app regardless of where the bottleneck. The big value prop here is write less code, manage less code. Right? Do less on a per application basis. That's the big idea with WebAssembly, and if there's one thing you take away from this conversation tonight, I hope it's that concept. Now, there are many different WebAssembly distributions. I work on one that's inside of the CNCF that's called CNCF wasmCloud. And what wasmCloud endeavors to provide is a platform and ecosystem for enterprise WebAssembly, where we start with the same core CPU that you find at in the Bytecode Alliance called WasmTime, and then we build a CLI and a workflow, some signing capabilities, and build as much of that into the platform as possible to give you an open source WebAssembly platform. And the demos that we do tonight will be all compatible with wasmCloud. I will use our commercial product because it's got a prettier UI for some of it, but everything we're going to look at tonight works with the open source. I'm super excited about the progress in wasmCloud. Last year at this time, we had around 80 developers. This week, we just found out we have over 440 developers that have contributed to wasmCloud, which absolutely blows my mind to get out there. And we have created this CNCF wasmCloud as a sort of WebAssembly distribution. Now, CNCF wasmCloud is open source. It's in a foundation. It's got governing members from Google, from Capital One, from Cosmonic, and lots of other companies. And it really focuses on being an easy way to adopt WebAssembly. As I mentioned earlier, WebAssembly is a standard out of the box. It gives you numbers in and numbers out, but we sort of help to uplift that to give you an application workflow around writing this. We build on lots of other open source software and have baked in things like OpenTelemetry, NATS for message bus, and everything else. As a part of going incubating, which we anticipate will happen this fall, we just completed our security audit. wasmCloud is written in Rust, and we absolutely crushed our outside security audit by trail of bits. So it's a pretty secure platform that you can leverage for application development. Now, as I mentioned, what we're trying to do here is raise that abstraction for developers so that developers can simply submit their business logic. You know, I need a hello world here. And then at runtime, you can use components that are written in any language that come together to provide capabilities like key value, like HTTP, like SQL, and other components. Most powerfully, though, those components can be also started and scaled at runtime. Again, we're trying to drive down what the developer provides to a small amount as possible. Now, earlier we were looking at the Docker spec, which I think everybody in this room, based on your personas, is probably familiar with. But essentially what we have underneath in wasmCloud is an application spec. So when we think about the power that DevSecOps brings to Docker and your CI/CD platform, what we're really creating here is something like a DevSecOps, where you can, I just made that word up on the fly, trademark DM, that was great. But this DevSecOps means that you can actually build your applications at runtime with the latest components that get attached. And we come back to the slide we looked at earlier, what should each application provide? It should be as little as possible because we want platforms to provide the rest. Now, what we focus on, where we actually have a huge nexus of adoption, let's think about where WebAssembly is already showing up. As I said earlier, the future is already here, just not evenly distributed. I have a map here of maybe some notable WebAssembly projects that you're likely to be using. Let's maybe scan through some of these. 1Password, Adobe Photoshop, Amazon Prime Video. Amazon Prime Video did a blog post where they talked about running on 8,000 unique endpoints, all the different CPUs, iPhones, Android, and they do that by targeting WebAssembly. It enables the team to innovate faster, and they were able to cite increase in application that they have there, application performance that they have. Cloudflare Workers, Fastly Edge, Envoy and Istio now use WebAssembly for their plugins and components. Kubernetes can natively run WebAssembly through a project called Run Wasm. Things like CNCF wasmCloud, Figma, Google Earth, Microsoft Blazor, Microsoft Flight Simulator. WebAssembly is being adopted in all of these places for one common reason. There's lots of times when we want to enable customability or run someone else's code, and I don't trust anyone. And WebAssembly is one heck of a great sandbox. We can come back to this a little bit later, but I want to try to get to a demo where we are installing WebAssembly. So CNCF wasmCloud, we made the decision as a community to sort of track the standards. We're on track to hit WASI 0.2, which is the next big release of the standards this fall. Distribution ship for Windows, Linux, Mac, Android. We run on all the clouds, and we've got a pretty decent library of components. Go ahead. This fall is now. Tentatively we've said November 20th is the meeting where we're going to approve the standard. Yeah. My guess is that it may slip till the December meeting. It would happen in December, but that's just my guess right now. I can tell you there are developers in right now working, and there will be developers in all weekend working to get this done. You know, and I'm talking to that slide I showed earlier. I was talking to Chad. We went out for dinner beforehand, and I was on it. Literally, was coming off a conference call with developers from like 8 different companies, and we're all going to be in on Saturday working on getting these things across the line. Now, I want to emphasize something here, and we'll emphasize it when we get into the demo momentarily, but when we think about what you really care about, especially the management people, are achieving these ilities of software, is composing software that's reliable, that's scalable, that's highly available, and that usually means you're running it in more than one place. So when we focus on distributed WebAssembly, it's not just, you know, BMW using wasmCloud in their cars. It's using WebAssembly across regions and letting those components be used from different regions. So that's a key sort of a value prop that we're going for. I'll come back to that in just a moment. All right, so let's get to demonstration time. This is the fun stuff. All right, so everybody got their phone? Get your phone out. Let's demo God's be praised. Let's all deploy WebAssembly live. Okay, so what should happen is basically what you see over here on the right. If you click this, you should get a little Google form. I may peek over somebody's shoulder to see how things are going. And then when you get to your screen, it's maybe not designed for the best mobile experience, but just click install and go now. You know, just pick your Google off and go from there. Great. Oh, so good. It works. All right, launch. Launch now. I love it. All right, so what the heck did you just do? All right, let's take a look. Essentially what you did is you logged in, and our PAS, which is in developer preview, essentially just created a whole WebAssembly cluster for you. Now this is not competitive with Kubernetes or containers, right? They're different levels of abstraction. It's completely compatible with everything that you're using today and all of the incredible investments that you've made in securing those platforms, but it's not dependent upon them. You can also run this natively on hardware. So you probably have something like this that popped up on your screen. And what you're looking at on your screen, if you just peek up here for a moment, are WebAssembly components. And we're gonna look at source code in just a minute, so try to stay with me on this one, or let me know if we need to slow down or go through this. Here's my business logic for the app that you just deployed. It's called a XKCD random comic thing. If you click on the wormhole or on the URI, it should give you a random XKCD comic. Now, the developer only needed to write the logic to say, use this, go open up a web client, and go get me a comic, and then serve it back out to this web server. And the web server and the web client are both attached at runtime. That's the latest version, and can be scaled independently. If we get slash dotted, we get 1 million requests come in, it will automatically launch per invocation, and these are really, really small, so we can keep up with those loads. We can use our hardware more efficiently, and most powerfully, we scale back down to 0 in the other direction. Each request, we're arbitraging microseconds versus network time, which is milliseconds. So the delay of cold starting a WebAssembly runtime is negligible because it's, you know, a thousandth of a 50 millisecond a network connection, right? That's what we're arbitraging here. That's the big idea. So for things like FAS, think like AWS Lambda, but with WebAssembly, that's a done deal, right? Microsoft's already launched theirs in AKS. We haven't. I have no knowledge of what Amazon may or may not be doing, but this is a game changer for FAS services, and I think that use case is just going to get swallowed by WebAssembly right away, just gobbled up, and you'll never know it. Just like you don't know when you're using Cloudflare or Fastly, really good technology just fades into the background. But I think what we're doing is perhaps a little bit more interesting. Now, here you're seeing that these components can connect and talk to each other. But what CNCF wasmCloud enables underneath the hood is for these components to not even be local to each other. These components can be operating across infrastructure that can be running on any cloud or edge, including your own. So right now, on my version of what I installed here, I'm actually running around 40 different WebAssembly instances, including in different clouds, different CPUs, and in different operating systems. And these applications can automatically self-form, self-heal, and find their components wherever they are. So if we have a cloud outage and one of these components disappears, it can find a compatible component that satisfies its request automatically. Now, underneath the hood, we do this through the magic of NATS, which is another is a message bus in the CNCF. But let's look at the WebAssembly itself. In the WebAssembly standard, I'm going to open up some WebAssembly files here. Let's take a small C program. We could have our small programs here, but in the WebAssembly standard, essentially there are 2 different specifications that are provided for WebAssembly. I'm going to open up VS Code here in the browser just by pressing period. I'm sure you guys all know that trick. But let's look at these. So the first is a .wac file, which if you look is our human readable instructions here of WebAssembly. It looks almost like assembly code to be honest. And if we look at the top here, this is actually a component. So you have all these numbers that are the actual program. And then what the component does is it sort of wraps it and says, well, hey, here's my highly structured imports and exports. And what that maps it to is a standard definition of like a string or a vector or something like that. And what that means is that these are now interchangeable between languages, because the guest language boundary gets assimilated here, if you will, and now the Go strings match JavaScript strings, and JavaScript strings match Rust strings. Now, there is the executable here that we don't really want to look at, but let's kind of visualize what these components then look like underneath the hood. So each one of those WebAssembly instances is completely secure. It has its own memory, its own table, its own globals, and it's locked down. And then it has a set of imports and exports. That's the difference between a WebAssembly module and a WebAssembly component. Now, the security people in the back, a couple of you probably think in terms of least privilege and deny by default. Think about the ABI, the application boundary interface we get with containers. Somebody want to throw out one? Take maybe 2 different answers to this. Syscalls, right? 534 syscalls on Linux or so, or maybe POSIX, right? Would be our ABI. And well-managed Docker and Kubernetes locks down, the critical system calls, and then tries to intervene on the rest. Or maybe you run something like gvisor, which gives you another pair of virtualization on top of that. Here's what's really awesome about these WebAssembly components. This ABI that gets created when you create the modules only includes those modules that you import. So it's not denied by default, it's share nothing. So if you don't import anything into your module, and you have some sort of an exploit or some sort of miscall, you don't have access to file open, right? You don't have access to a file unless you give it specific access to those modules. So from a security perspective, this means two things. One, this completely changes the game and moves us to this idea of component-driven security. You're familiar with this. Everybody's been on the web, you've been on a conference call, and you come into some website and it says, I want to use your camera or your location. Right? I'm sorry, I said component-driven security. This is capability-driven security. This capability-driven security has been adopted by your iPhone and by your MacBook, and it's already adopted by your browser. And WebAssembly brings it to your applications as well. That capability-driven security gives us another huge benefit. We now have an ABI, an application boundary interface, that's portable. When we say portable, what we mean is that it's portable everywhere. So let's take a look at what I mean by when we think about WebAssembly being portable everywhere. Telco. What we mean is that think of the challenges of running an application in a browser and on a Linux shell. Like, it doesn't make sense. You're like, well, I have syscalls here and I have web GPU here. WebAssembly is now that virtual platform that we can use to compose applications that are now truly portable. In reality, I would say there's really three realms of application development, and I'm not up at 100,000 feet. I'm on the top of the mountain right now. We really have web apps, we have Linux-based stuff, and then we have embedded stuff. Stuff that doesn't even run on Linux. Think small microcontrollers. WebAssembly is being adopted across all three of these domains, and the WebAssembly component is poised to be the last application target that we'll ever need. And these are some of the many reasons why I'm excited about WebAssembly.
So,
go ahead.
Liam, how do we stop people importing stuff?
How do we stop people from importing a huge collection of stuff? I love that question. I think that there's a couple different ways to answer it. And let me pull up this little wasmCloud security map. So the first way that we do that is that when you import a WebAssembly component, you have the ability to sort of decide what you're importing, what you're starting. Because of that format, and we looked at the raw WebAssembly module, you can inspect in advance and say this is importing wasmSQL and wasm HTTP and the various components. So you can inspect them at runtime and sort of limit what you want in your platform. That's you get in this core WebAssembly module. Now this component model idea gives us the shared nothing linking and virtual platform layering. And then WASI, which is how we describe interfaces, gives us capability-driven security. Think like you ever use like Swagger, design-driven development, right? Define your API spec, and then auto-generate interfaces down from there. What we're doing is we're taking all of these application best practices and we're baking them into the platform, right? And requiring their use at each step. Now, when you get to something like a CNCF wasmCloud, we use virtual platform layering to upgrade you even further. We take a WebAssembly component and then we sign it, and then you can configure your wasmCloud runtime to only launch apps that have been signed with that key, or to only launch apps that you know of or use these capabilities. Down at the component layer and across WebAssembly distributions, because there's wasmCloud, which I'm obviously quite passionate about, but there's also a lot of other great WebAssembly distributions that are out there as well. What I want to emphasize is that different WebAssembly distributions can choose to satisfy capabilities in different ways. You could have your runtime, think like CNCF wasmCloud, have HTTP baked in. Or what wasmCloud is actually really good at is actually custom capabilities. So you can actually load capabilities that you didn't have before at runtime. So you could create something called wasmSensors, and you could load that then. So you have a variety of, you have a whole layer of controls to prevent that. Did I answer your question?
I'm interested in things like say analytics to work out what people are actually using.
Yes, when you get WebAssembly, you get what I showed on screen here. You have this ability to inspect these apps, understand what they're importing. And you could scan this and see what capabilities they're trying to use in advance. And there's two different ways that you can even. There's two standards for running your WebAssembly. You can actually JIT it, just-in-time compile it, and that is useful if you want to stream in, like I get part of the WebAssembly module, I execute part of it, think like downloading from the web, or you can pre-compile these things and have any number of steps that you might do in advance. So I think you've got multiple methods. Yes, sir.
Well,
it is the same technology, yes, and part of the same standard. Different WebAssembly engines like V8, SpiderMonkey, or wasmTime have a support for various levels of the standards. The WebAssembly module is today what everyone supports. The WebAssembly component is what's finished in WASI.2, and that is the idea is that this will be portable across everywhere in the same way that WebAssembly modules are today. Now, there's an interesting question here when you talk about using GPUs or device-specific capabilities. Today, WebAssembly is still very nascent, and the reality, when we're out helping customers build WebAssembly apps, we run into things that just aren't supported in WebAssembly yet. I was sharing with Chris this morning a story about how we helped a customer to get Randall and crypto supported in WasmTime today, so that they could do cryptographic signing of components and applications for their application that they're building. So it is still early days. There are various strategies for using things that would never be supported in WebAssembly. Let's think about like a GPU. WebAssembly, if it's a virtual machine, it's got some little RISC instruction set. It doesn't have all of the powerful CPU that's native to an NVIDIA, not a GPU person, some NVIDIA GPU. So there are standards that enable us to have a interface definition for talking to components that are outside of the WebAssembly sandbox. But again, you have that IDL that defines what can pass between them, the security layers, the capability grant. Did that help to answer your question?
No.
Yes. wasmCloud actually even has a JavaScript library that runs in your browser. So there are many different WebAssembly distributions that are out there that enable this kind of portability. This is powerful stuff, and it is a lot to wrap your brains around. There's no doubt. Yes, sir. Let me find a picture of a network for one of the apps that was just launched here. So we had a big group of telcos that they're working on a case study for us, and they had this awesome infographic. Let me see if I can find it. I'm gonna find it online. They had this awesome interactive site that showed their whole network. All right, so this is an example of somebody that they went to their version of the CNCF, which is called TM Forum, and they talked about all the apps they're building. They actually won an award for innovative apps in telco, and they're going to do a case study in the CNCF for us. So here's an example of the 180 different POPs that they're running in 31 countries. Now, what they were struggling with was, wow, I can't run Kubernetes across these regional edges. It doesn't scale very well, so I'm going to run 180 different instances. And then in each instance, I'm going to have a container running with everything on, whether it's being used or not, right? If I need it accessible, it's got to be on. So they were really excited to see if they could create really slim microservices that worked with other things that were in Kubernetes. So they have some weight here in Paris, where one of their major data centers is. So some of their core data services are still served out of here, but they're using wasmCloud to pull the microservices to the edge. And I believe they're running, I don't know where they're running them, but I believe they're running them in containers on some edge device. But they're a lot smaller, they're a lot more efficient. And when we get down to things like energy efficiency and swap, size, weight, and power, those are concerns that really come in bear on cost and capability. So I think there's a lot of strategies. Actually, you asked that question. There's a lot of different strategies for how we do these microservices. I'll give you another great example. Fastly and Cloudflare. Now, Fastly and Cloudflare operate closed networks with a limited set of capabilities. If you're Fastly, or if you're building on Fastly or building on Cloudflare, you can use those capabilities that they provide. But those are still very powerful. And Fastly and Cloudflare have incredible networks, 4,000 plus hosts or more that you can deploy to run your microservices. Where we see a niche with wasmCloud is in the ability to run these microservices, and this is on your handout as well here, is the ability to run these microservices across any cloud or edge, including your own. Now, this has the Cosmonic branding on it, but the way that wasmCloud works is we use NATs as our message bus that connect all of the wasmCloud processes in what we call lattice, and then you can use capabilities regardless of where they're deployed in that lattice. So if you want more reliability or more availability, you simply run more copies of those capabilities in different places. And that gives you those enhanced abilities of software. So wasmCloud isn't a very opinionated distribution of WebAssembly, but what we're trying to build is the enterprise version of WebAssembly. The one that takes into account the fact that you want everything signed, and there's no such thing as an unsigned component in wasmCloud. There's no signing in regular WebAssembly, but those are the things that we want to build into the distribution by default. Did I answer your question about server-side microservices, or was it was my answer just too broad? You can ask again if you want to maybe scope it a little more. I really want to satisfy you here. Sure. The exact same way that you adopted any of those other platforms. wasmCloud typically is serving HTTP REST endpoints. What's behind that REST endpoint may be different. It could be auto-scalable WebAssembly components, but to other application services, it just shows up that way. So I don't think that it's any different.
You rebundle your service.
Yes, that's right. And the keynote for next week is KubeCon. The keynote for Wasm Day, which is on Monday, are two different WebAssembly startups that go on stage and take one of those WebAssembly components, and they run the same component on both platforms, which is what you want as a consumer. Part of this core theme and thesis for what the WebAssembly community has accomplished this year that I think makes this whole reason why I'm here is this standard called the WebAssembly component. Before the WebAssembly component, there were lots of ways to build WebAssembly modules, but they're almost too open-ended, right? to think about how we would bring portable interfaces. WebAssembly components is like the Docker moment for WebAssembly. If you were in the container wars, 15 years ago, you probably remember before we standardized on Docker, there was a lot of competition. There was Boxcar, Flatcar, one that was called yet another container distro from Google. It's like Yagi 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 or something like that, right? And then Docker took the best from everybody, and then ended up donating their IP, and that became the artifact that we built around for this entire epic of tech. Now, the previous epics were a little bit different. We had this idea of a virtual machine. The ABI was the CPU, and we had some slightly different ways for building them. But we probably all standardized on Packer, and Packer could spit out an AMI, for Amazon, or an ISO for VirtualBox, or whatever. But the key idea was that we had one ABI to execute on. And here we have, the container ABI. Pardon me. Component, the ABI gets completely shattered, right? There is a proposal out there to make POSIX the ABI for WebAssembly, but I think that's a really terrible idea for a lot of reasons. The biggest is, why would I want to give each application all of POSIX? We have a great abstraction for POSIX. It's called a container, right? What in that proposal called WASI, when we talk about turning your application into Lego blocks, what that means is that your applications, each one of these ABIs can be iterated independently. So underneath the hood here, as we're building WASI SQL or WASI HTTP, we can rev this world very quickly, and things that are outside of this world aren't impacted. If you create your own standard, we're actually working with a consortium now on WASI sensor and what that would look like. That WASI sensor can iterate very quickly without blowing up the entire world like POSIX, right? With an idea of WASI POSIX, you would have to get everything right in your ABI on the first pass, and you'd have to support the entire world on the first pass, which is also something that would never happen.
Can you talk a bit about Greenfield? Yeah.
Great.
How like all the old problems and present a web?
Yeah, one major benefit that containers and virtual machines had over WebAssembly is that you could lift and shift. If it ran in a virtual machine, I could just lift it. I could put Adobe Photoshop and just throw it in there and put it in right? I could put my database in a container, and yeah, there's going to be problems, but it's not there. But I think to some degree, you can do that with WebAssembly. More at a library layer, though, because this is a different level of an abstraction.
But then you haven't got rid of all your old
problems. By own problems, you mean that
old problems.
My old problems, yes. The WebAssembly is not going to replace containers, right? There are things that we haven't replaced, AS400s, or microvaxes or vaxes yet. There will still be things that are very tightly coupled to Linux and have been optimized incredibly heavily to run very well in Linux, and that is not going away anytime soon. I would encourage you to think of the difference between running in a container and cloud native. That's really what we're getting at with But this is a phenomenal point. WebAssembly, I think, is a greenfield technology, which is where I see it growing the fastest is across those distributed edges, which I think is the big theme for tomorrow. This last decade was the great lift and shift into the clouds. The next decade is bringing our compute to the data. And I think there's compelling reasons for that when we think about what's driving a technology. I mean, did containers drive the public cloud, or did the public cloud drive containers? I think it's clear that the public cloud drove containers, right? Containers were just the technology we used to accomplish that business purpose. The business purpose that people are struggling with now is essentially this, how do we go to the edge? And that starts with even a definition of what do we mean by the edge. And I think the compelling themes that we're operating under there are, not just latency and determinism. Your Tesla needs to run things local, Tesla Powerwall needs to run things local. Not just that the data's on the edge, but things like privacy and security or regulatory reasons. Facebook got whacked with 1.2 billion fine for pulling European data back to the US, where lots of things in the US could happen. So we're seeing the world being balkanized already, and what that translates to is now I need to run more things horizontally. And if I'm running more things horizontally, I'm back to a world because of the cold start time that, oh my God, this is going to be crucifyingly expensive. And that's the reality that people are trapped in today, is I need to go horizontal to be close to my users for privacy, for regulatory, and it's incredibly expensive to do so. So I think that these business purposes right here on this screen, these 5 reasons are my best 5 reasons for what will drive WebAssembly. Because otherwise WebAssembly is just tech, right? There has to be a business purpose for what we're doing here. Phenomenal question. What programming languages can I create in WebAssembly? Let me break it into 3 different groups of languages. There's our statically compiled languages, Rust, C, Zig, C++. All of these things work awesome in WebAssembly today. They're just slam dunk support. Rust is the language that's most closely associated with WebAssembly. There's our interpreted language. And actually just today, Alon Zakai, the developer that I mentioned, had done the initial hack called Wasm.js that took C code and transpiled JavaScript, just tweeted like 2 hours before this meeting that WASI garbage collection is now supported in V8. So they've just put a generic garbage collector into the Chrome engine for all of our interpreted languages. Now, if you're not a language nerd, these languages, essentially have a little runtime here: C#, Go, Python, and JavaScript. And there's 2 different ways to support those languages in Wasm today. When you create your Wasm module, you actually bring the interpreter with you. Now that makes your Wasm module bigger, but it lets you do proprietary garbage collection like what we have with Go. But what Alon Zakai announced earlier today, coming out of the WASI-GC subgroup, which is in the W3C, these are like internet standards, is a generic way to bring garbage collectors to the WebAssembly runtime, which will let us keep those small. Now, the white whale that's not supported yet is Java, right? That's 50% of the app market or something like that, in my view, just finger in the wind. And it's in flight. There are JVM-based languages like Kotlin that have just gotten over the line this year. A group at VMware just finished that. So Java is, I would say, imminent, but it's likely somebody's key delivery for 2024. Great question.
For existing applications.
That's a great question. And $5 per question. You're $100 tonight. It's great. Thank you for this. Containers can. I'm only teasing. I was only teasing. We just met earlier tonight. I'm just kidding again, right? Look, there are compelling reasons today for why you might use a virtual machine versus a container. It has state. It's a database. Lots of things like that. Those reasons for why containers would start with, it's already tightly coupled to Linux. It's going to be hard to decouple, right? Greenfield stuff, edge stuff is obviously strong proposals for here. And what we're seeing people adopt at a super high level would maybe be services that we want global and really fast. Things like authentication, DDoS, those kind of components I'm seeing show up in a lot of WebAssembly projects. Or pulling the early responsive part out to the edge with through caching and using WebAssembly modules there. So WASM in front of memcached, essentially, right? Something like that would be a strategy. That's the kind of stuff that we're seeing people do. I think there's a lot of room for innovation here, including in wasmCloud, which I was shocked this week. Last year at this time, we had around 80 contributing developers to wasmCloud. This week, we just finished our application for incubating. We have over 400 developers. So for all I know, somebody's already doing it in our community. It blows my mind. how quickly these things. Great. Did I answer your question?
Yeah, well, my other be I had before retired and was going was that monolithic approach.
Sure.
I used to think that decompose it into services that are going to run properly. And now, to me, it sounds like even more accomplish that because many are going to say skills, I don't know how to do it. It sounds great, we love it, but
So I'll give you. Let me talk in generic ways about one of our early design partners. This is a big company. Everybody in this room knows their name. Everybody uses them. They build 5,000 or so applications, and some of the applications cost them $500 a month to run, and some of those applications cost $500,000 a month to run. So very quickly, eyes go to the bigger applications. Right? This is expensive. Now, why is it expensive? In the case study we did with Adobe as an example, they picked an app that did background removal, and that was very expensive. Two reasons. One, to run all the servers and you have to run a lot of them globally to do it. And two, egress charges were ruthlessly expensive. So they said, well, what if we wrote this in Wasm? And so we re-implemented part of that in Wasm. You can go to CNCF.io and you can read this case study. And when they found out that in 80% of cases, they could actually even run that Wasm in the customer's browser. Now, here's what happened from a timing perspective. In the core the Java Spring Boot based microservice, the round trip time was around 400 milliseconds. It was like 150 milliseconds to get there, 100 milliseconds to do my thing, and then 150 milliseconds back, and I get a clean background for my image. In the new version, the whole thing happens in 40 milliseconds because I take out all the network transfer time. It happens local in the browser. I'm not paying for compute, and I'm not paying for the network. So it was good. Same algorithm, same results. It was faster. Don't tell me you can have it all. Only with WebAssembly.
I mean, well, that's why I use the WebAssembly component to graph. Everybody else is written.
That's right. This reminds me very much of 2012 leading into the release of Kubernetes. It's a time where everybody recognizes the problem and the need for the next abstraction in tech, that the cost of the way we do things today is not working, and we have lots of business purposes that are driving these new technologies. I from my perspective, and look, I'm opinionated. I'm an investor. I'm the CEO of a WebAssembly startup, so I'm selling picks and shovels, right? For the WebAssembly gold rush. I think it's a done deal. Like, I look at the evidence, I look at who's building WebAssembly, I look at the apps, I look at Thomas Tongues did this incredible blog post. If you don't follow Thomas, he's actually one of the few bloggers I think that is just amazing. What he called the article "Flare Across the Cloud." He did this blog post earlier this year, and he just commented about the current average growth rates of clouds and major cloud providers versus some of these edge providers, which are WebAssembly shops, by the way. And these WebAssembly edge shops are still growing at 50% now. They're starting from a different scale. Yeah, AWS is already everywhere, so it's hard to maintain 50% growth at that rate. But I continue just to see reason after reason, adoption after adoption, in order to think that WebAssembly, it's already here. And there was a time in 2016 when people would still argue with you and say, oh, maybe it's going to be Mesosphere is going to be the winner. And if you were already in the Kubernetes ecosystem and you'd been to the early KubeCons, you already knew that was over. You already knew that it doesn't, once it gets the mind share and the technology takes off, I think we're past that point. It's already tipped. The avalanche has already started at the top of the mountain, and now it's just how long does it take to get down the hill. That's my own view, and I do feel very strongly about that. But I've tried to present a lot of different evidence tonight and notable use cases and the way I see the world, and I hope that it helped. Chad, I'm way over time, but I appreciate it. I hope that this was a good time. I'm going to wrap up here. I'll stay as late as people want to answer questions. I'm very accessible online. I hope that if you enjoyed anything tonight, you might consider joining the wasmCloud community, which is a CNCF project. You can come right to wasmcloud.com for install. There's the new security audit. You can click this little Slack button here at the bottom, and you're in a Slack with 1,000 other WebAssembly enthusiasts at companies all around the world. Or there's WasmCon, there's WasmIO. Monday next week we have Wasm Day. So there's a lot of great content to come out and meet. In the back, there are stickers if you didn't get any, not only for CNCF projects like wasmCloud, but also Cosmonic, my company, and the Bytecode Alliance, which is one of the trade groups here that organizes a lot of the WebAssembly like reference implementations and stuff like that. That's what we build here in this group. Okay, thank you so much for your time. Have a great night.